Greetings, fellow Earthlings. Today we embark on an extraordinary journey to our celestial neighbor Mars. Today we journey to the Red Planet, a celestial neighbor that has captivated our imaginations for centuries. Mars, with its mysterious allure and potential for harboring life, has always been a focal point of our cosmic curiosity. Mars, with its rusty hues and enigmatic landscapes, continues to surprise us. Its surface, marked by vast deserts, towering volcanoes, and deep canyons, tells a story of a planet that once had conditions very different from the barren world we see today. Recently, NASA's Curiosity rover beamed back images that have set the scientific community abuzz. These images are not just ordinary snapshots, they are windows into the planet's geological past and possibly its biological history. Imagine a landscape adorned with peculiar hexagonal structures resembling giant honeycombs or waffles. These formations are unlike anything we've seen before on Mars or any other planet in our solar system. That's precisely what Curiosity stumbled upon in Gale Crater, a region suspected to have once held a vast lake. This crater has been a focal point for scientists because it offers clues about Mars' watery past. These intriguing formations, ranging in size from a few centimeters to several meters, have left scientists both baffled and excited. The hexagonal shapes suggest a complex history of environmental conditions that we are only beginning to understand. Their unique geometric patterns hint at an underlying process, a story etched in Martian rock. These patterns could be the result of ancient climatic cycles, volcanic activity, or even the presence of water. Could these be the remnants of ancient microbial life? The possibility that these structures were formed by biological processes is tantalizing and could revolutionize our understanding of life beyond Earth. Or are they the product of geological forces yet unknown? Mars has a history of volcanic activity, and these formations could be the result of lava cooling and cracking in a unique way. The answers, my friends, lie in unraveling the secrets held within these Martian mysteries. Each rock, each formation, is a piece of the puzzle that scientists are eager to solve. The discovery of these honeycomb structures has ignited a firestorm of speculation and scientific inquiry. Researchers are now analyzing the data, conducting experiments, and formulating theories to explain these enigmatic formations. We are on the cusp of a new chapter in our understanding of Mars, a chapter that may rewrite the history of our solar system. The implications of these findings could extend beyond Mars, offering insights into the processes that shape planets and the potential for life elsewhere in the universe. Join me as we delve deeper into this Martian enigma, exploring the potential explanations and the profound implications of these extraordinary findings. Together, we will uncover the secrets of the Red Planet, and perhaps, in the process, learn more about our own place in the cosmos. Let's talk about the leading theory, wet-dry cycles. This theory is fascinating because it connects the geological features we observe on Mars today with processes that are well understood on Earth. Imagine a Mars of the past, a planet much warmer and wetter than the arid world we see today. Picture a landscape where rivers meandered through valleys and lakes dotted the surface, creating a dynamic and vibrant environment. Rivers flowed, lakes shimmered, and the atmosphere was thicker. This thicker atmosphere would have supported a more stable climate, allowing liquid water to persist on the surface for extended periods. Now picture Gale Crater, once a vast lake bed, periodically inundated with water. This crater, with its deep basin, would have collected water during wetter periods, creating a substantial lake. As the Martian climate shifted, the lake would have experienced cycles of flooding and evaporation. These cycles are crucial because they drive the deposition and crystallization processes that form unique geological structures. During these cycles, dissolved minerals in the water would have been deposited on the lakebed. Each flooding event would bring a fresh supply of minerals, which would settle out of the water as it evaporated. As the water evaporated, these minerals would have crystallized, forming intricate patterns. The process of crystallization is influenced by various factors, including the concentration of minerals and the rate of evaporation. Over eons, these repeated cycles of wet and dry conditions could have sculpted the curious hexagonal formations we see today. These formations are not just random, they are the result of precise natural processes that occur under specific conditions. Think of it as nature's own version of a cosmic honeycomb maker, using water and minerals to create these mesmerizing patterns. The hexagonal shapes are reminiscent of honeycombs, which are also formed through natural processes on Earth. The wet-dry cycle hypothesis is particularly exciting because it suggests a Mars that was once hospitable to life. If Mars had stable bodies of water, it could have provided the necessary conditions for life to develop and thrive. On Earth, similar processes create environments teeming with microbial life. Wet-dry cycles can concentrate nutrients and create niches where microbes can flourish, suggesting that ancient Mars might have had similar microbial ecosystems. Could these Martian honeycombs harbor evidence of past life, perhaps fossilized remnants of ancient organisms that once thrived in these watery environments? The possibility of finding such evidence is one of the most compelling reasons to continue exploring Mars. The possibility is tantalizing, urging us to explore further. Each new discovery on Mars brings us closer to understanding the planet's history and its potential to support life, making the search for these honeycomb structures all the more important. The discovery of these hexagonal structures on Mars has sent ripples of excitement through the scientific community, particularly among those searching for signs of extraterrestrial life. Why the buzz? Because similar structures on Earth, known as biosignatures, often point to the presence of life, either past or present. These biosignatures are essentially the fingerprints of life left behind in the geological record. These structures can be formed by the interaction of living organisms with their environment, leaving behind telltale patterns. For instance, microbial life can create mineral deposits that form these hexagonal shapes, a process that can take millions of years. Now, I'm not saying that we've found definitive proof of life on Mars just yet. The scientific method requires rigorous testing and validation, but the possibility is certainly intriguing. The presence of these formations suggests that Mars may have had conditions suitable for life at some point in its history. These Martian honeycombs, with their potential link to water and cyclical processes, provide a tantalizing clue. Water is a key ingredient for life as we know it, and the presence of these structures could indicate that water was once abundant on Mars. They offer a glimpse into a Martian past that may have been far more dynamic and life-friendly than we once thought. Imagine ancient rivers, lakes, and perhaps even oceans teeming with microbial life. Imagine the implications if we were to find evidence of past life on Mars. It would be one of the most groundbreaking discoveries in human history. It would fundamentally alter our understanding of our place in the cosmos, proving that life is not unique to Earth, but rather a phenomenon that can arise wherever conditions are right. This would open up new avenues for the search for life on other planets and moons in our solar system and beyond. The search for life beyond Earth is a profound endeavor, and these Martian honeycombs have brought us one step closer to answering that age-old question, are we alone? The journey is far from over, but each discovery brings us closer to understanding the mysteries of the universe. As we continue to explore Mars and other celestial bodies, we must remain open to the possibilities that lie ahead. The universe is vast and full of surprises, and who knows what we might find next. The future of space exploration is bright, and with each new mission, we inch closer to uncovering the secrets of our cosmic neighbors. Whether it's Mars, Europa, or beyond, the quest for knowledge continues. So as we look up at the night sky, let's remember that we are part of something much larger. The search for life on Mars is just the beginning of a journey that could redefine our understanding of life itself. Section 4. Earthly Encounters, Parallels in Our Backyard. To understand the significance of these Martian honeycombs, we don't have to venture far. Right here on Earth, we find similar formations, offering valuable insights into their potential origins. Take a look at the salt flats of Badwater Basin in Death Valley, California. These flats, sculpted by cycles of flooding and evaporation, display striking polygonal patterns remarkably similar to those observed on Mars. These terrestrial counterparts provide compelling evidence that the wet-dry cycle hypothesis holds water, so to speak. Just as these processes shape our own planet, they likely played a crucial role in sculpting the Martian landscape billions of years ago. By studying these earthly analogs, we gain a deeper understanding of the forces that shaped Mars, allowing us to piece together the planet's history and its potential for harboring life. Section 5. Curiosity's Toolkit, Unveiling Martian Secrets. Of course, none of these groundbreaking discoveries would be possible without the ingenuity of NASA's Curiosity rover. This robotic explorer, equipped with an arsenal of scientific instruments, has been tirelessly roving the Martian surface since 2012, sending back a treasure trove of data. Curiosity's arsenal includes the MAST camera, or MASTCAM, which captured the stunning images of the honeycomb structures. Then there's the ChemCam, which uses a laser to analyze the chemical composition of Martian rocks and soil. And let's not forget the Rover Environmental Monitoring Station, or REMS, which provides valuable data on Martian weather and climate. These instruments, working in concert, allow scientists to study the Martian environment in unprecedented detail, unraveling the secrets locked within its rocks and landscapes. Curiosity's findings continue to rewrite our understanding of Mars, paving the way for future missions